Welcome to the Explainer. Today, we're going to try and decrypt the whole alphabet soup of online security. SSL, TLS, and SSH. These are pretty much the invisible guardians of our digital lives, and we're about to pull back the curtain and see exactly how they work.
So let's start with something you've probably seen 1,000 times. You see that little padlock icon click into place next to a web address. But what's it actually doing? It's definitely more than just a cute icon. It's a promise, a sign that there's some seriously complex security stuff happening behind the scenes to keep you safe.
Okay, so here's our game plan. First, we'll talk about why sending secrets online is a problem to begin with. Then we'll look at the web's digital padlock and a kind of secure remote control. After that, we'll dive into how the magic of all this works, what happens when it breaks, and wrap up with why this is all just a never-ending battle.
Right. First things first. Why do we even need all this security in the first place? Well, the thing is, the internet, by its very design, is like a giant open network. Think of it like shouting a message across a crowded room.
Picture this. You're ready to buy something online. You type in your credit card number. That number has to travel all the way from your computer through who knows how many routers and servers to get to the website. And the big problem is that anyone sitting anywhere along that path could, potentially, just grab that data and read it plain as day. Not good.
And that brings us to the first hero of our story, the technology that was built to solve exactly that problem. This is what we can call the web's digital padlock. The solution is a protocol called Transport Layer Security, or TLS for short. You can think of it like a digital armored car for your data. It basically builds a secure encrypted tunnel between your browser and the website. It scrambles all your information so that even if some snooper manages to intercept it, all they see is a bunch of unreadable gibberish. This is the S in HTTPS, and it's the tech that makes that little padlock show up.
Now, you've probably heard people say SSL, right? Secure Sockets Layer. Well, as you can see here, SSL was the original version back in '95. But, hackers find flaws, things get old, and it had to evolve. So in 1999, it got a major upgrade and a new name, TLS. So even though a lot of people still say SSL just out of habit, what we're all actually using today is its modern, much more secure descendant, TLS.
But let's be real, we do more than just browse websites. What if you need to do something way more complex, like, securely manage a computer that's thousands of miles away? Well, that's a whole different problem that needs a whole different tool.
And that's where SSH, or Secure Shell, comes into the picture. So unlike TLS, which is all about protecting website traffic, SSH is for creating a secure channel to actually control a remote machine. This is the absolute go-to tool for system administrators and developers, the people who build and maintain the internet, who need to log into servers and run commands securely.
And this shows you exactly how it works. Honestly, the best way to think about it is like a secure remote control for a server. A developer can connect, type a command on their own laptop, and that command zips through an encrypted tunnel, runs on the server, and the results get sent right back. It's like you're sitting right in front of the machine, but you could be anywhere in the world.
Okay, so we've got TLS for websites and SSH for remote control. They both create these awesome secure connections. But how do they actually do this magic of scrambling and unscrambling data? Well, the answer is a field called cryptography.
At the heart of it all are two main ideas. First, you've got symmetric encryption. This is kind of like having a single secret key that both locks and unlocks a box. It's super fast, but you have this huge challenge. How do you get that secret key to the other person without someone stealing it? Then you have asymmetric encryption, which is the really clever solution. It uses a pair of keys. Think of it like a mailbox. There's a public slot that anyone can use to drop a letter in, but only you have the private key to open the box and read the mail.
But, and this is a really big but, this awesome system of public and private keys isn't perfect. In fact, its greatest strength, the fact that you can share your public key with anyone, can actually become its biggest weakness if a bad guy gets in the way. And this brings us to one of the most classic hacks out there, the man-in-the-middle attack. This is where an attacker, let's just call him Black Hat, manages to slip himself right into the middle of a conversation between two people. Let's call them Alice and Bob, and they have no idea he's there.
Okay, so here's how the heist goes down. Alice wants to send Bob a secure message, so she sends him her public key. But Black Hat is listening in, and he snatches that key out of the air before it ever gets to Bob.
And now for the old switcheroo. Black Hat sends a public key to Bob, but it's not Alice's key, it's his own. Bob gets the key and thinks, great,
Now I can talk to Alice securely. He has no reason to be suspicious.
So here's the crucial part. Bob writes his secret message and encrypts it, but he's unknowingly used Black Hat's public key to do it. So when he sends it, Black Hat just intercepts it again, uses his own private key to unlock it, and boom, he can read the entire message.
And this is the most brilliant, diabolical part of the whole trick. To cover his tracks, Black Hat takes Bob's message, re-encrypts it using Alice's real public key that he stole earlier, and just forwards it along to her. So Alice gets the message, Bob thinks he sent it securely, and neither of them has a clue that their private conversation was just completely compromised.
This whole attack just perfectly illustrates that cybersecurity isn't something you can just set up once and forget about. It's not a destination, it's a process. It's a constant, ongoing effort to defend against threats that are always changing.
And what this all really shows us is that security is a relentless cat-and-mouse game. The tools we've talked about, TLS and SSH, they're incredibly powerful, but they're just one piece of a much bigger puzzle. And that leaves us with one final thought, right? In a world where new attacks are being cooked up every single day, the race is always on to build the next, better digital padlock, just to stay one step ahead.